Okay, so now we're getting into trig graphs, and this is new. This is the pre-cal standard. And we're going to look at transformations of, or just basic information from these. Sine and cosine, they are technically the same function, just shifted over. So before I get any further, sine function always starts at your origin, and it goes up and then down. Cosine always starts up above, and it goes down and then up. These are what the normal parent functions look like. Understand that these are continuous functions, so they will continue going on and on and on and on. Always continuous. Same for cosine. On and on and on. Both directions. Okay, so you see how they look the exact same. It's just when we are getting information from them, you either look at it as a sine function or cosine function. I think that's the part that's kind of tricky. But they do look very similar. I mean, they could go either way, just depends on how you're looking at the function. So this is what we're going to talk about. Some information you guys need to know. Amplitude Okay, so your amplitude is the amount the graph travels above and below its midpoint. So what I like to do is I like to at least figure out where my midpoint is. And so it's just part that breaks it up in half. Here is just the x-axis for both of them. So your amplitude is how far above or below its midline. So above, it's 1, below 1, above 1, below 1. So both of these are 1. So your parent one will always be 1. Let me just label these. Okay, your phase shift is how far the function is shifted horizontally. So we see that this right here, I've repeated the function. So if I were to start over here, my phase shift would be -2 because it comes all the way over here. So your phase shift is it shifting left and right. So for this one, it's 0. Vertical shift is how far the function is shifted vertically. So if this midline were to come up here, then that would be my vertical shift would be at 1. And so my new midline is 1. Period is how far it goes from one point to another. And actually, what you're going to see is a lot of times you're going to see that these coordinates are pi and 2 pi. Because it comes from the unit circle, which uses pi and 2 pi. And when you get to pre-calculus, you'll see that a little bit more and understand that a little bit more. This comes directly from your unit circle, which most of you don't even know what I'm talking about, which is fine. Just know it's always pi and 2 pi. This is your normal period, which is 2 pi. This gives you what your k value is. And so all you do is take 2 pi, which is the general form, divided by k, which in this case is 2 pi. 2 pi divided by pi, 2 pi is 1. So you wouldn't even put that in there because this is the parent function. Your parent function is literally just f of x equals sine of x. So since this is our parent function, there's nothing to add. Everything's 1, 2, it's whatever the normal part is. So now we're going to look at if we don't have parent functions. So I would make sure, pause the video, take notes where you need to. And now let's get started. So we're going to find information from this graph. So first thing I like to do is I always like to find my vertical shift and find my midline. So I see up 10 down 10 all the way. This is my midline. Ooh, not my line, midline. So there is no vertical shift. Your amplitude is how far above or below it is from this midline. And I just see, I know it's 10, either way I look at it. So my amplitude is 10. your period is start to finish. And so first it's figuring out, well, what kind of function is this? Well, I see it starts all the way at the top, comes down or whatever. So this is a cosine function. So I need to find start to finish. So start to finish for this one, it starts here at 0 and it ends all the way here, which is 4 pi. So my k value is 4 pi. And remember, when we look at finding the period, we do 2 pi divided by k. So 2 pi divided by 4 pi. Pi's go away, and this becomes 1/2. So our period is 1/2. Phase shift is if it moves left or right, and it doesn't. It still starts at 0. So our phase shift is 0. Now we write the equation. Amplitude goes in front. Then it's cosine. And if we look at our notes, so remember, amplitude goes first, and then your period goes right out front. So it's going to be 1/2 x. All right, let's look at another one. So this one doesn't look like sine or cosine. Nothing starting at the origin and nothing starting up here. So there is going to be a phase shift involved in this. And here, you pretty much can choose whichever one you want. I'm going to go with sine for this one. And I'm going to look at this portion right here. I was looking at the positive value area. It's just easier for me. Your midline is still here. And so amplitude first. How far up does it go? 2. Period. It's from start to finish. So it ends at 2.25 pi and begins at 0.25 pi, which gives us 2 pi. So our period is 2 pi, and we're going to use the same formula we did up here. 2 pi divided by this value, which is 2 pi. And 2 pi divided by 2 pi is just 1. So our period is 1. And then our phase shift, where did it shift over? It's shifted over to 0.25 pi. So now we write the equation. Remember, amplitude goes in front. Parent function is cosine. And then we figure out where the phase shift goes. Phase shift, right here, remember we changed the sign just because it's going in parentheses like we did with transformations. You change the sign. So it started at 0.25 pi. It's positive. We're going to change it to a negative. So x minus 0.25 pi. When we look at this, remember it's a continuing function. So our domain is all real numbers, or negative infinity to positive infinity. Your range, again, is your y values. So what's my lowest y value? -2. And our highest y value is +2. So you can still do the same thing with these that you would do any other function. All right, next one. And I didn't realize this was 0. So here we're doing the sine function. So let's look at, still always like to start here. That's where I prefer. So here's our midline. And there's our function that we're looking at. You can use any part. I just always prefer the positive part. Amplitude, how far up and low does it go? 10. Your period, actually we can do phase shift first. Where does it start? At 0.25 pi. And it ends here at 1.25 pi. So we're first going to subtract to find how long it is. And you get 1 pi. And then we take our formula, which is 2 pi, divided by this value, and you get 2. So the period is 2. Now we take this information and put it into our equation. So we have 10 cosine, and then period is going to go in front of x, phase shift goes behind. So our period here is 2x. Our phase shift is, remember it's positive, we change the sign, so it's negative 0.25 pi. All right, last example. This says using cosine, and you can start from top or bottom. So I'm going to show you what happens here. If I were to start here, still the same thing, it's just upside down. It's okay. There is no phase shift here. It's not shifted left or right. The period we'll look at in a second. But here the amplitude is 2. And I just want to make clear that this is flipped. It's reflected over the x-axis. So there's going to be a negative that goes in front. So it's negative 2 cosine. We'll have some value, x, no 0. So it's just this number that goes in front of x, which is our period. So it starts here at 0, ends here at 0.67. So we're going to take 2 pi. Sorry, you can't see that. 2 pi divided by 0.67. So when we do that, we end up getting 9.37. So that's going to go here. Now I want to show you what happens if we were to choose this from anywhere else, because I see that there is a cosine function right here. I look right here. My amplitude is still 2, but there's no negative in front. My period should be the same. I go from 0.33 to negative 0.33, which is 0.66. Same thing, close. So 0.66, 2 pi divided by 0.67 or 0.66 is going to be that 9.37 x. But now there's a phase shift, and your phase shift is negative 0.33. Remember, you take the inverse of the sign, which is a positive 0.33. And you get the same function either way. So that's basic level of sine and cosine. There is a tangent graph. There's inverse trig graphs. There's a lot more that's involved in this. This at least gives you an idea for some of those ACT questions. It lets you at least have exposure to sine and cosine graphs so that you can't say you've never seen them before, and hopefully you can piece together some of the information. I just don't want to overwhelm you guys because this is an entire unit in pre-calculus, and I have 15 minutes to share this with you. So I just wanted to go over some of the words you're going to hear, what the graphs look like, at least give you that kind of exposure to it so that you are a little bit more equipped for the ACT. Just know I have my live sessions on Wednesdays at noon. Make sure to be there and ask me any questions. Bye, guys.